Training. Is ammonia. It is made up of nitrogen and hydrogen, or its common formula is NH3. It's a colorless gas with a pungent odor. It's highly soluble in water, and its uses are fertilizers, refrigeration, cleaning products, and industrial processes, amongst many. Ammonia is used in agriculture for fertilizers. It's an anhydrous ammonia directly injected into the soil, providing a concentrated source of nitrogen for crops. It's highly efficient but requires careful handling due to its gaseous state. What is ammonium nitrate? It's produced by reacting ammonia with nitric acid. It's a popular fertilizer due to its high nitrogen content and solubility in water, making it readily available to plants. What is urea? It's formed by reacting ammonia with carbon dioxide. Urea is the most widely used nitrogen fertilizer worldwide, known for its high nitrogen content and ease of transport and storage. Industrial section, it's used for refrigeration systems. Food processing, ammonia refrigeration systems are extensively used in food processing plants to keep products at the required temperatures, ensuring freshness and safety of all our food products. For cold storage, it's used in large warehouses quite frequently to store perishable goods like fruits, vegetables, and meats. And in some of our common ice rinks around the country, ammonia is used to maintain the ice surface in skating rinks due to its high efficiency and cooling capacity. Also, around our houses, we use ammonia quite a bit in our cleaning agents. For glass cleaners, we use products like Windex because they use ammonia to clean glass surfaces without leaving streaks. In our all-purpose cleaners, ammonia is found in many multi-surface cleaners for its ability to cut through grease and grime. And in our oven cleaners, ammonia helps to break down tough, baked-on food residues in ovens. For processes in our industrial section, wastewater treatment, ammonia is often used to neutralize acetic components in wastewater, making it safer for discharge into the environment. In the production of rubber and plastics, ammonia is used in the production of synthetic fibers and plastics, acting as a stabilizer and neutralizer. And in explosives, ammonium nitrate derived from ammonia is a key component in the manufacture of explosives used in mining and construction. There are many health and safety considerations when using ammonia. Some of the health hazards are inhalation. Inhalation can cause respiratory irritation, coughing, and shortness of breath. High concentrations may lead to lung damage. There's issues with skin contact. Ammonia can cause burns and irritation. Prolonged exposure may result in severe skin damage. And of course, we can't forget about one of our most precious systems, eyes. Ammonia can cause severe irritation, potential blindness, and damage to the cornea. Here are some health and safety considerations to think about when using ammonia. Personal protective equipment, or PPE. Always use chemical-resistant gloves, such as those made from nitrile or rubber, to prevent skin contact with ammonia. These materials provide a barrier against the corrosive nature of ammonia. Goggles and face shields. They protect your eyes from splashes and vapors. By wearing these safety goggles or face shields, ammonia can cause severe eye irritation and damage. Use of respirators. Always use appropriate respirators, such as those with ammonia cartridges, to protect against inhalation of ammonia gas. This is especially important in confined spaces where ammonia vapors can accumulate. Ventilation. Ensure that areas where ammonia is used or stored are well ventilated to prevent buildup of harmful vapors. This can be achieved through natural ventilation or mechanical systems. Fume hoods and exhaust systems. In laboratories and industrial settings, the use of fume hoods or exhaust systems to capture and remove ammonia vapors at the source. This helps maintain a safe working environment. Here are some storage guidelines to think about. Store ammonia in a cool, dry, and well-ventilated area to prevent pressure buildup and reduce the risk of leaks. The use of appropriate containers. Use containers specifically designed for ammonia storage, such as steel tanks. These containers should be able to withstand the pressure and corrosive nature of ammonia. And separate ammonia from incompatible materials. Keep ammonia away from incompatible materials such as acids, chlorine, and oxidizers to prevent dangerous chemical reactions. Some safety considerations. Handling procedures. Follow SOPs and SDS. Always adhere to established SOPs and SDS for handling ammonia to ensure consistency and safety. These procedures typically include guidelines for safe handling, storage, and disposal of ammonia. Regular inspections. Regularly inspect equipment for leaks and ensure all connections are secure. This includes checking pipelines, valves, and storage tanks for any signs of wear, corrosion, or damage. Proper tools and techniques. Use appropriate tools and techniques to minimize the risk of spills and exposure. This includes using ammonia-compatible equipment and ensuring that all personnel are trained in safe handling practices. Emergency procedures. First aid measures. If someone inhales ammonia, move them to fresh air immediately. If symptoms such as coughing, difficulty breathing, or chest pain persist, seek medical attention promptly. In case of skin contact, rinse the affected area with plenty of water for at least 15 minutes. Remove any contaminated clothing to prevent further exposure. If ammonia gets into the eyes, rinse them with water for at least 15 minutes. Seek immediate medical attention to prevent serious eye damage. Readily available contacts. Have emergency contact numbers readily available in case of an accident on site. This includes local emergency services, the National Response Center, or NRC, at 800-424-8802, and any other relevant local or state emergency response guidelines. Safety considerations. Training awareness. Provide regular training sessions to employees on the hazards associated with ammonia. This includes understanding its physical and chemical properties, potential health effects, and safe handling practices. Safety measures. Train employees on the proper safety measures to take when working with ammonia. This includes the use of PPE, proper storage techniques, and emergency response procedures. Spill management. Barriers and absorbent materials. Use barriers such as dikes or berms and absorbent materials like sand, clay, or commercial spill kits to contain ammonia spills. This helps prevent the spread of ammonia and minimizes environmental impact. Immediate action. Act quickly to contain the spill and prevent it from spreading to other areas. Ensure that all personnel involved in the containment processes are wearing appropriate PPE. Neutralizing agents. Use neutralizing agents like dilute acetic acid or other weak acids to neutralize ammonia spills. This helps to reduce the toxicity and corrosiveness of the ammonia. Application techniques. Apply the neutralizing agent carefully to the spill area, ensuring complete coverage. Follow the manufacturer's instructions for the correct dilution and application methods. Safe removal. Follow proper cleanup procedures to safely remove and dispose of ammonia-contaminated materials. This includes using appropriate tools and equipment to collect the neutralized ammonia and any absorbent materials used. Disposal. Dispose of the collected materials according to local regulations and guidelines. Ensure that all waste is handled and transported safely to prevent further exposure or environmental contamination. Storage of ammonia. Storage guidelines. Cool, dry, well-ventilated area. Store ammonia in a cool, dry, and well-ventilated area to prevent pressure buildup and reduce the risk of leaks. Proper ventilation helps disperse any ammonia vapors that may escape, minimizing the risk of inhalation. Appropriate containers. Use containers specifically designed for ammonia storage, such as steel tanks. These containers should be able to withstand the pressure and corrosive nature of ammonia. Ensure that all containers are properly labeled and inspected regularly for signs of wear or damage. Separation from incompatible materials. Keep ammonia away from incompatible materials like acids, chlorine, and oxidizers to prevent dangerous chemical reactions. Store these materials in separate, clearly marked areas to avoid accidental mixing. Handling procedures. Use proper PPE. Always use appropriate PPE when handling ammonia. This includes chemical-resistant gloves, safety goggles or face shields, and respirators if necessary. PPE helps protect against skin contact, eye irritation, and inhalation of harmful vapors. Follow standard operating procedures and SDS. Adhere to established SOPs and SDS for handling ammonia to ensure consistency and safety. These procedures typically include guidelines for safe handling, storage, and disposal of ammonia. Regular inspections. Regularly inspect equipment for leaks and ensure all connections are secure. This includes checking pipelines, valves, and storage tanks for any signs of wear, corrosion, or damage. Promptly address any issues to prevent accidents. Ammonia in refrigeration systems. System components. Compressors. Compressors are the heart of the ammonia refrigerant system. They collect ammonia vapors generated in the evaporator and compress them to a higher pressure and temperature. This process reduces the vapor volume and transfers the ammonia to the condenser. Common types of compressors used in ammonia systems include reciprocating and screw compressors. The choice depends on the system capacity, operating temperatures, and load profile. Condensers. Condensers handle the refrigerant after it exits the compressor. They reject the heat absorbed by the ammonia from the evaporator and compressor, converting the high-pressure ammonia vapor into a high-pressure liquid. There are different types of condensers, including air-cooled, water-cooled, and evaporative condensers. Evaporative condensers are commonly used in ammonia systems due to their efficiency. Evaporators. Evaporators absorb unwanted heat from the target areas. The liquid ammonia refrigerant vaporizes as it absorbs heat, returning to the compressor as low-pressure vapor. Evaporators are used in various industrial applications, including cold storage and food processing, to maintain low temperatures. Operational safety. Regular maintenance and inspections. Schedule regular maintenance and inspections of all system components, including compressors, condensers, and evaporators. This helps identify and address any signs of wear, corrosion, or leaks. Promptly replace any worn out or damaged components to ensure the system operates safely and efficiently. In refrigeration systems. System components. Leak detection systems. Invest in advanced leak detection systems to monitor ammonia levels continuously. These systems can include solid-state sensors, infrared sensors, and electromechanical sensors. Ensure that the leak detection system is connected to an alarm system that alerts operators immediately in case of a leak. Training for operators. Provide comprehensive training for all operators on the safe operation and maintenance of ammonia systems. This includes understanding the properties of ammonia, proper handling techniques, and emergency response procedures. Conduct regular safety drills to ensure operators are prepared to respond effectively to any ammonia-related emergencies. Detecting an ammonia leak promptly is crucial for safety. Here are some common signs of an ammonia leak. Strong pungent odor. Ammonia has a very distinct, sharp smell that is easily recognizable. If you detect this odor, it could indicate a leak. White cloud or fog. Ammonia leaks can create a visible white cloud or fog, especially in areas with high humidity. Hissing sound. A hissing sound near ammonia equipment or pipelines can indicate a gas leak. Eye, nose, or throat irritation. Exposure to ammonia vapors can cause irritation in the eyes, nose, and throat. If you or others experience these symptoms, it may be due to an ammonia leak. Difficulty breathing. Ammonia inhalation can lead to respiratory issues such as coughing, wheezing, or shortness of breath. Nausea or vomiting. Inhaling ammonia can also cause nausea or vomiting in some individuals. If you notice any of these signs, it's important to take immediate action. Evacuate the area. Move to a safe location away from the leak. Notify emergency services. Contact local emergency services or a hazardous materials hazmat team to report the leak. Administer first aid. Provide first aid to anyone affected by the leak, such as moving them to fresh air and rinsing their eyes or skin with water if they have been exposed. Response and spill management. Emergency response plan. Evacuation procedures. In the event of an ammonia leak or spill, evacuate the affected area immediately. Ensure that all personnel move to a safe location upwind and uphill from the spill to avoid exposure to ammonia vapors. Establish clear evacuation routes and designated muster points where employees can gather safely. Conduct regular drills to ensure everyone is familiar with these procedures. Communication protocols. Implement a system for quickly notifying all employees of an ammonia emergency. This can include alarms, public address systems, or digital alerts. Incident Command System, ICS. Use an ICS to manage the emergency response. Designate a clear chain of command and ensure all responders are aware of their roles and responsibilities. First aid measures. Move the person to fresh air immediately. If symptoms such as coughing or difficulty breathing persist, seek medical attention promptly. Rinse the affected area with plenty of water for at least 15 minutes. Remove contaminated clothing to prevent further exposure of the skin. Rinse eyes with water for at least 15 minutes should ammonia make eye contact. Seek immediate medical attention to prevent serious eye damage. Spill management. Containment strategies. Use barriers such as dikes or berms and absorbent materials like sand, clay, or commercial spill kits to contain ammonia spills. This helps prevent the spread of ammonia and minimizes environmental impact. Act quickly to contain the spill and prevent it from spreading to other areas. Ensure that all personnel involved in the contaminated process are wearing appropriate PPE. Neutralization methods. Use neutralizing agents such as diluting acid or other weak acids to neutralize ammonia spills. This helps reduce the toxicity and corrosiveness of the ammonia. Apply the neutralizing agent carefully to the spill area, ensuring complete coverage. Follow the manufacturer's instructions for the correct dilution and application methods. Cleanup procedures. Follow proper cleanup procedures to safely remove and dispose of ammonia-contaminated materials. This includes using appropriate tools and equipment to collect neutralized ammonia and any absorbent materials used. Dispose of the collected materials according to local regulations and guidelines. Ensure that all waste is handled and transported safely to prevent further exposure or environmental contamination. Regulatory compliance and standards. OSHA regulations. Permissible exposure limits. The Occupational Safety and Health Administration, OSHA, has established permissible exposure limits, PELs, for ammonia to protect workers from harmful exposure. The OSHA PEL for ammonia is 50 parts per million as an 8-hour time-weighted average. The National Institute for Occupational Safety and Health, NIOSH, recommends a lower exposure limit of 25 parts per minute as a 10-hour time-weighted average and a short-term exposure limit of 35 parts per minute for 15 minutes. The American Conference of Governmental Industrial Hygienists sets threshold limit values for ammonia at 25 parts per minute as an 8-hour time-weighted average and 35 parts per minute as a STEL. Hazard communication standards. OSHA's hazard communication standard requires employers to inform and train employees about the hazards of chemicals they may be exposed to in the workplace. This includes proper labeling of containers, maintaining safety data sheets, and providing training on the safe handling of hazardous chemicals, including ammonia. Globally Harmonized System, GHS. The GHS aligns with the Globally Harmonized System classification and labeling of GHS, ensuring consistent communication of chemical hazards through standardized labels and SDS formats. Environmental Protection Agency, reporting requirements for spills. Under the Comprehensive Environmental Response, Compensation, and Liability Act and the Emergency Planning and Community Right to Know Act, facilities must report releases of ammonia that meet or exceed the reportable quantity of 100 pounds to the National Response Center, state and local authorities. Facilities must provide immediate notification of any release to the NRC at 800-424-8802, the State Emergency Response Commission, and the local Emergency Planning Committee. Risk management programs. The EPA's risk management program requires facilities that use or store significant quantities of hazardous substances, including ammonia, to develop and implement a risk management plan. This plan must include hazard assessments, prevention programs, the emergency response strategies to minimize the risk of chemical accidents. 5-year updates. Facilities must revise and resubmit their risk management plans to the EPA every 5 years, or sooner if there are significant changes to the facility or its processes. Understanding and adhering to ammonia safety protocols is crucial for maintaining a safe and healthy work environment here at Ironsmith Fire. By following proper handling procedures, utilizing appropriate PPE, and staying informed about regulatory requirements, we can minimize the risks associated with ammonia exposure. Regular training, emergency preparedness, and effective spill management are essential components of our safety strategy. Let's commit to these practices to ensure the well-being of all employees and safe operation of our clients' facilities. It is the responsibility of all operations managers and site foremen to ensure they are prepared for the possibility of being around ammonia on a work site. Contact the client's EHS manager or safety rep to get a clear understanding of what the client and the site directly need from you and your team to ensure compliance with all their ammonia rules and regulations to ensure you have a safe and secure job site. Thank you for your attention and dedication to safety.